This is a demonstration of using Cubelets in the elementary school classroom. For more information on inner-city science, please visit innercityscience.org. This is a demonstration of how to use Cubelets to apply both math and science standards for first and second grade. We know that in first and second grade we're dealing with rectangles and squares. So we'll be dividing these into different fractions, talking about how to talk about those fractions, and then actually doing a little mini experiment with these shapes. You're going to need 4 cubelets that have wheels on them. I recommend beforehand making sure that your wheels are all going in the same direction. You're going to need some power cube, and then you're going to need one of the source cubes to make sure that you have something that's giving it an input so that your output can be delivered. We have chosen the input cube that has the spin knob because it's just the easiest to control. So one of the things that you want to talk to your students about is you want to talk to them about their shapes. So you can point out that when you've got the 4 cubelets lined up like this, you have a square. And then you can talk about that when you split the cubelets like this, you've split it into 2 even sections, or you've split it into 1/2. You can then divide the cubelets even further, and you can say now you've split your 1 square into 4 even parts. So now each of these squares represents 1/4 of your cube. You can rearrange your cubes in all the different directions. You can say that that's one. Then looking at your wheels, you can make it so that the wheels all line up the other way, which is only easy to see if you see that one. So that's a different shape. And that's how you can use it to kind of help your students understand the concept of fractions. Now what we're going to do to use this as a science experiment is I have a little race course measured right here. And we're going to actually time our cubelets in 3 different shapes. And you might want to draw the wheels in there. So like here our wheels are all going like this. Here our wheels are all going in this direction. And then here our wheels are going in this direction to help your students kind of see what the difference is. Since this is a science experiment, you should always have your class make a prediction. So have them guess which shape they think will move across this the fastest. We've chosen 25 inches. That's an arbitrary distance. You could do this over however long you wanted. And then you just get started. So you're going to need a stopwatch, which a normal watch will do. You could use a clock. You could use your phone. Lots of options. I'm going to use a phone just because that's what I have. I'm going to make sure my power cube is on, attach it to my input cube, and I'm going to set that on top. I'm going to make sure he's on all the way. Oops. And then I'm going to say ready, set, go. And I time him, and he takes 2.71 seconds to get across. I have the wheels all going this way, so I write this with 2.71 seconds. Now I'm going to rearrange him so that he's going in this one. Make sure your power cube is off or it becomes very challenging. So I'm going to set my cubes on there again, and I'm going to say on your mark, get set, go. We're going to say that one is 3.53, even though he fell over. That's his own fault. And now we're going to set it up in our cube, and we're going to do the same thing one last time. And we're going to say on your mark, get set, go. And that one is 2.54. You might want to have a student on the other end who can be the carrier or the catcher of your cubelets. So in looking at this guy is our fastest. And then you can ask your students to try to guess why that one was fastest. So this is a demonstration for 4th and 5th grade standards using cubelets for both applying them in math and science. To do this, you will need at least one power cublet, at least one input cublet. The output cublet that we are using is the wheels. I have several of the blank cubelets. I also have a speaker cublet. These you can use any of them that you want. And then on the side I have 6 other wheel cubelets. You will want to make sure that your wheels line up before you start going so that all of your wheels are going in the same direction. But generally we're going to walk kids through how to deal with fractions and equivalent fractions using our cubelets. And then we're going to perform a little science experiment with them. So the first thing that we have set up here is just a cube with our cubelets. So we've got our 4 cubelets, and you can see that right now the wheels make up 1/2 of our number of cubelets. So one of the things that you can then ask your student is, what would be how many wheels would I need to add if I added one more cublet? How many wheels would I have to add so that I still had that 1/2 of my wheels as cubelets? And this is a really nice visualization because they can see that to make the same shape, I need to add one more wheel. I can do the same thing with what happens if I add another cublet. And again, you've got that great visualization of, oh, I see, I need to add one more set of wheels. So now I know that 4 out of 8 is equivalent to 2 out of 4. And the same thing with I know that 3 out of 6 is equivalent to 2 out of 4 because both of those make up 1/2 of my numbers. And I have this going all the way up to, I could do this with, 2 more of my guys. So I can take this all the way up to 6 out of 12 is the same thing as my 4 out of 8 is the same thing as my 3 out of 6 is the same thing as my 2 out of 4. So it's just a really great way that you can help kids visualize. Now turning this into a science experiment is kind of fun because what we're going to do is we're actually going to take different time measurements for our different fractions worth of cubelets. So what you want to have written on the board is something like your number of cubelets, and then you can work with the students together to create your fractions of cubelets, and then we're going to time them. This first one that I have is 1/2, but I'm actually going to vary from that 1/2, and I'm going to create different combinations so that students can really start contemplating how this works. The biggest thing to remember is you must at least have 3 cubelets. You have to at least have your wheels, your power, and your input. So keep that in mind when you're setting this up. Like I said, I'm going to make sure that my wheels are going the same direction before I start this. With the 2 cubelets, we have not had a lot of success of getting it to go all the way across our track, but we'll try it anyways. So I have my little timer set up. I say on your mark, get set, go, oops, and I start them, and you see they don't stay up very well. So we'll say that they took 6 seconds, or 6.44 seconds. Now I'm going to start going with my 3s. So what I'm going to do is I'm actually going to create it so it's just a little tripod. So now you can ask your students, what's my fraction here? I have 3 that are wheels out of a total of 5. So my fraction here is 3/5. So now again, I make sure my wheels are all going in the same direction. They are. This guy should stay up just fine, so he should be pretty easy. So I say on your mark, get set, go. And he takes 2.44 seconds. Now we can add one of our third blocks. We can make it so that now we have 3 cubelets, but now we have 3 out of 6, which is equivalent to 1/2. And now I can time this guy, and I can say on your mark, get set, go. And he is 2.37 seconds. And now you can keep going with all of these different numbers of cubelets until you get really nice data, and then you can either have your students graph it on a graph, or maybe you even want to have them just put it on a number line so that they can line up which this works better on. Again, I didn't write it on here, but since this is a science experiment, we should always have our class make a prediction of what they think is going to work the best. And for this one, you can do number of wheels and what fraction.